Okay, right. How are you guys doing? Yeah, you okay? That's good. That's good. So today I only have 3 exercises that I want us to do. We're still continuing with probability. Probability. Uh, I think let's start with let's actually start with revision exercise 4. Let's do things in order. Let's do things in order. Revision exercise 4. Okay, and here, what are they saying? Sure, actually, I need to duplicate this before. Okay. Right, so here, under revision exercise 4, what they are saying is there are 20 contestants in a weightlifting competition. What is the probability of correctly predicting the contestants? Sorry, correctly predicting which contestants come first, second, third, and fourth in the correct order. Okay, given, all right, sorry, give your final answer as a fraction in its simplest form. Okay, so we have 20 contestants, right? And they want us to find out what is the probability of correctly predicting which contestant comes first, second, third, and fourth. All right, so here we can see order obviously matters, right? Okay, so firstly, what type of probability question are we being asked here? What type of probability? And remember, we discussed something to this effect when we went through the slides. What type of probability are we looking at here? Nope, it's not conditional. Conditional is if this happens. Oh, sorry, what's the probability of this happening given that this has happened? That's conditional. It's on the board, on the projector. Permutations. Okay, so let's recap to see what is permutations all about. Here it says is the number of distinct ways of selecting a subset of R objectives drawn from a large group of objectives where the order of selection of objectives is important. All right, so here we have 20 weightlifting contestants, right? Any one of them could win. Any one of them could come second. Any one of them could come third. Any one of them could come fourth. But we're saying, what is the probability of us predicting the order in which these guys attain their positioning, at least from 1, 2, 3, and 4. Okay, so we have to apply this formula to get that probability. Okay, and n in this formula represents what? The total number of objects from which to select. So let me actually do this. Let me copy this slide, and then we take it to our question there. But then we don't want the whole slide. Let's crop. Can I crop? Shh, guys, we are still having class, right? Okay, so this is not allowing me to crop. Okay, but let me just do this rather than, because all we want is this formula. Oops, I went about it the wrong way. You do it with this. Oh, it's not allowing me. Okay, so it doesn't allow me to take images. Okay, it's fine. So the whole point is that n is the total number of objects from which to select. We know that any one of these 20 weightlifting contestants could be selected. So obviously, it's going to be 20 as your numerator. But again, we have to have that exclamation mark, which you'll see is in your calculators. Then we said, well, okay, the formula says, we then say 20 minus R. What is R? R is the number of objects selected at a time, all right? Or in other words, the total order that we have, okay? So we then say, okay, we know that to be then 4, okay? And then whatever the difference there, we have exclamation mark. So that's how we then need to approach this particular question, okay? So let's pull out our calculators, and each of us need to do this, because if you do this for the first time in the test, chances are you might struggle. So I plug in 20, then I go second function, exclamation mark, that's for a sharp. Okay, and then what I'm doing personally is, because we know that the 20 is the numerator, right? I'm storing my results into A. Now, I don't know how the storing function works on you guys' other calculators. Okay. Because we're going to use it. Isn't we going to divide the 20? Yes? Yeah.
So would it be able to do like that grouping when you just put the values in?
You could, if you can get your brackets right. Right? You could. You could. And it depends on your calculator. I know if I do it in mine, it's going to come out. It's going to go crazy. Okay. So, yeah. Do it the way it works for you, and that you remember. It's no issues. Okay, so I've done that. Then, obviously, 20 minus 4 is obviously 16. So, 16. Okay, so my denominator, I store it in B. So then I'm saying recall A divided by recall B. Okay, what are you guys getting?
116.
What are you guys getting? That's what I'm getting. Okay. Who made a mistake? Oh, okay. Right. So then once you're done with this, remember we are looking at getting probabilities. Okay. So we know that all probabilities lead to 1. Okay. So then you then say 1 divided by this 116. 280. Okay, and that will give you the probability. Okay, but if you check, you're going to get quite a few zeros. So what they've actually done is they've left it like this. The one comes from, remember, all the possible outcomes, right, of an event equal 1. So here, when it comes to this, we just have to then also divide by 1. And that's how we then arrive at the probability for this specific. Remember, we are saying, what is the probability of us guessing who comes first, second, third, and fourth, and in the right order? Okay, so that's how we get the probability of that particular event. Yes.
I'm not understanding. So we need to take that value, which is what, divided by 1.
Divide 1 by that value we got. 100%. Okay. So if you actually calculate, you're going to get 0.00. You can tell me how many more zeros? I think it might be 2 or 1 at least. Store C. Okay, so I've got 1, 2, 3, 5 zeros here. When you say divided by 1?
1 divided by.
Yes, 1 divided by.
Yeah.
2 zeros.
Yeah.
Maybe it's because we only have 2 decimal places.
Maybe that's why. And your amount?
Oh yes.
So you just got 0.00, right? Yeah.
When? How? How did you change the Excel? 599.
How many? Check how many decimals you have. Because I've opened up mine and I'm getting
9 zeros. I mean 9 after the decimal and then 10 negative 6.
Let me see.
He's changed his calculators.
I can't. I don't use it.
This
is what I'm saying. So this is letting you know. This is letting you know. When you see an X, and maybe you guys are getting the same thing. You see an X there, right? And then you've got negative 6. It's letting you know that you've got 6 zeros. Then this number. So if you round up this number, you're going to get a 9. Makes sense? Okay.
So in the test, if we see that it should say 0.00 up until 6.
This is why they're leaving it like this, as a fraction.
But how would I know about the 9 stuff with a calculator like this?
This is why I think the best thing for you, I would advise that you open up your calculators maybe to at least 6 decimal place. Because that can throw you off, especially if you forget about it. And I only remember this because I was doing some other regression, some other stuff and then I got that weird looking answer. Then I had to search and see why does it actually communicate. So I would advise go to mode and you then open up the number of decimal places. The best way, quickest way to learn how to change your decimal is go on YouTube, because I don't know how to do it on your calculator.
So is the fraction used as 4 because the 0 becomes 0?
Whenever we do probabilities, we usually leave it either in decimal format or as a percentage, right? But I just see in the back of your books, they've left it like this. But again, when we do probabilities, it should be decimal or it should be percentage. So if we wanted, we could have said 0.0009%. Okay. Right. I don't advise if you're saying what I think you are saying. No, but learn your calculator, guys. Honestly, look. And look, this is advice to everyone. Anything mathematical, Get used to your calculator. The only way you do that is through practice. Checking YouTube videos for how do we do this, how do we do that, and you'll be home and dry, you'll be fine. But what I can tell you now, and even step aside, forget about your calculator for a second, you cannot cram something like statistics, like maths, like accounting. You're going to get caught out somewhere. Does that make sense? Because the way in which we can ask questions, it's so easy to just change one thing and it's a different question. So I'm just sharing advice. What you do is what you do, okay? But yeah, I just wanted to share that with you guys. Yes, ma'am.
If N equals to 1, and Y equals to 1, if N equals to 1.
If N
equals to 1.
Okay.
And Y equals to 1.
And Y
Equals to 1. It means that N is equals to Y, right?
Where is this coming from?
I want to ask you something.
Okay, but I don't know the fundamentals of.
Okay, yeah. Then 0,0009 equals to 8,599 times 10 to the power -6.
So again, I need to know where are we applying this? Are we applying it to the question that we are dealing with right now? Or are we applying this to regression?
What if I put this as my answer? Because it's the same as the
Chances are that's not on your memo. So it's not on your memo. So I would not advise you use this, because it's better you leave it as 1 divided by 116. That's right, yeah, 116 and then 280. Rather than leaving this answer. So I'd go back to the previous if this is what you produced, because I'm telling you now, your memo is not going to have that answer. And then you're just putting yourself at the backward, because what is the likelihood that your marker is going to take the time to say, but where is this person getting this answer from? Because remember, we're trying to obviously finish off with marking.
So this fraction by 7 is
Don't you mean this explanation mark?
I'm a mathematical genius.
Oh no, you won't get that. This is why I was saying you guys' calculators are fancy, because you can plug in the whole fraction. Okay. Okay, so she's figured out how to remove that. Okay, so I think guys just engage with her in the break or as we go along, just so we don't lose time here. So let's move on to the next question. An education institution has 15 part-time lecturers, okay? 8 of the lecturers have been selected for marking center team, okay? In how many different ways can the marking center team be selected from the group of part-time lecturers? Okay, now we're seeing we have 15 lecturers in total, isn't it? And now they're putting together a marking center, and they only need 8 of those 15 lecturers. So here now the question is, how many different ways can they then make up or select these part-time lecturers? Okay, so earlier we established that the question being asked was a permutation question. Okay, now we need to ask ourselves, is this a permutation question? Because if we look at it, are they asking for a specific order? Do they want things in a specific order? Or are they asking for different ways that we can select a team? Huh? You're saying wait. Ways, yes, it's ways. So order here doesn't matter. We just want to know how many different types of ways can we make up a team of 8 marking lecturers. Does that make sense? Okay, so this is not a permutation question. Okay, so let me remove this slide and then we go and look to see. Okay, so if we read now combinations rule, it says a combination is the number of distinct ways of selecting or arranging a subset of R objects drawn from a larger group of N objects where the order of selection of objects is not important. Okay, so this is the type of question that we are actually dealing with. Okay, and this time let me do this rather than taking the whole thing. Just screenshot. Okay, and remember, you guys are given formulas, but you obviously need to know when to apply which formula. Does that make sense? And here we can see this formula, when it comes to combinations, is slightly different. So here you can see we're looking for, let me do it here. Okay. We have 15 that we can select from, but the combination we need is of 8. Okay, so then we say N, total number that we can select from is 15, exclamation mark, and then divided by R we want 8, isn't? Exclamation mark, and then open brackets 15 minus R, which is 8, and then exclamation mark. Okay. Right. And then remember here, we're looking at the number of ways or number of combinations of 8 lectures that we can make. We're not looking for a probability, isn't it? Can you see that? Very important. So when we punch that into our calculators, what are we getting? 400 and? 6,135. Okay. So we got 6,435 number of ways that we can obviously combine these lectures. Yeah. Okay, then the last one. I think they've literally saved the best for last here, in my opinion. They asked the following question. Oh, actually, we can read it off the screen right here. Okay. They asked the following question. They say, you have to take a photograph of 12 family members. Okay, so 12 family members. Okay, sitting in a row of 12 chairs. Okay, in how many different ways can you arrange the family members on the 12 chairs? Okay, so here again, literally there's 12 and it's literally just your exclamation mark. Okay, because any of the 12 members can sit on any of the 12 chairs. Okay, and that will give you your number of ways that you can take this photo of your 12 members, 12 family members. It's a very big number. Even the last one is a very, very big number.
4 billion.
4?
4 billion.
4 billion. That is a very big number.
That's it.
Let me see.
So how come we just put 12 exclamation instead of doing that whole
So 47 billion.
With this one, remember?
Oh,
Yeah.
okay.
47 billion.
Okay. Ish, sorry.
900 million. 1,600. So, yeah. 1,600.
So that's 2 zeros.
That's what I'm, yeah,
1,006.
that's what I've got.
There's a one missing.
Where?
Take out
Before
one.
the six.
Before the 6. Oh, yes, 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 you're right. Sorry, my bad, guys.
479. No, 47. Yeah.
Okay, so that's your revision exercise 4. Okay, so yeah, we just need to go and practice those, get comfortable with those.
So what rule is this? So what is this rule called?
We've got permutations for the first one that we did, then we got combinations for the last 2.
So combination is different ways. Permutation is selected.
Yeah, permutations, we are concerned about the selection, we're concerned about the order, right? Whereas with combination, we're just saying, what are the different ways? Like, remember when we first discussed it, I was telling you guys about what, if I'm coming from Centurion to Varsity College Waterfall, what are the different ways that I can, routes that I can use to get to campus? That's obviously, we're not concerned about order, it's just about the different ways, the combination of ways that we can get you. So that was revision exercise 4. Now I want us to go to revision exercise 5. Something a little more interesting, I would think. Okay. So here they say we have a bag of 10 red and 8 blue marbles. You are asked to select 2 marbles from the bag. Okay? We are asked to select 2 marbles from the bag. The first marble selected will not be placed back into the bag. Okay. Right. So the first thing they're asking then is construct a probability tree for the various possible outcomes that may occur. Okay. So remember we said probability trees are things that we use in order to see the sequence of certain events. Remember we looked at this and we were talking about if 2 components, what's the probability that this product fails? And we said if the first component fails, right, then obviously the product has failed, right? If the first component is successful but the second component fails, the product still fails. And then we can also have a situation where both the first and second component fail and therefore the product fails. But then we also have a situation that the components don't fail. So can you see the different paths or different outcomes that can potentially happen? So in order for us to really assess all the different potential outcomes, the easiest thing is to actually have a decision tree. So we can actually see some sort of visual display of all our potential outcomes. So here we have to draw a decision tree, okay, to show the sequence of events that could potentially take place. So we know that we have 10 red and 8 blue. So in total, how many marbles do we have? So we have a total of 18 different marbles that we can select from. Does that make sense? So our probability is out of, is it making sense? Okay, but again, we have blue. Okay, maybe let me not do this in blue. Let me look for a neutral color here. Let's do the tree in black, and then we'll use the blue to, let's just pretend this drawing is so nice and neat. Right, so we know that we have blue and we have red, isn't it? Now I just want to see which one they put up. Okay, so they put red on top, so here's blue. So if we select blue, What's the probability of selecting blue?
8 by 10.
8. Oh, 8 out of 8.
How many blue marbles do we have?
8 out of 18.
So we have 8 out of 18. And then with red,
10 out of 18.
we have 10. Sorry, I know this is more pink than, or purple actually. Okay, let's just call that red. Right. So that's the first marble, right? Okay, so even here you could write if you wanted to. First marble. Marble. LE, ne? Is that right? Okay. Sure. Yeah, forgive me. We did spelling a long time ago. Okay. That's fine. Then we know it doesn't end here, right? There's more to this decision tree. So what are the other pathways that we can take from this point onwards? What are the potential outcomes or events that could take place? No, don't think about the probabilities. Right now, we just want to continue our decision tree, isn't it? It doesn't end here, is it? There's a possibility of selecting a red marble or a blue marble. Okay, same thing here. There's still a chance that we might select a blue marble or a red marble. Okay, so again, we then ask ourselves, okay, cool. If this is going to be blue, and what is the probability if we select another blue marble? What is the probability? This is where you are going. What is the probability that we select another blue marble? So on the second attempt, the second marble that we select.
So it's not going to be 7 over 18 over 17. I'm saying 7 over 18. Because it's not like the marbles reduce.
It doesn't come back, it does reduce.
7 out of 17.
We together?
Yeah.
All right, so 7 out of 17. And we're saying 7 because here we had already selected. So we're saying if we select another blue, that means we have one less. And obviously also from the total number of marbles we have one less. Because we don't put it back, isn't? Okay. Then there's also the probability that we can actually select a red after selecting a blue. What's the probability? What is the chance? Why'd you say 9? So maybe the way I've drawn my tree is bad. Let me do this. Sorry, that's on me. Let me make sure that we show that this is. So what we are saying is we are here, right, by blue. The first marble we selected was blue. And we said, okay, there's a chance we might select another blue. We said that's 7 out of 17. But from here, we can also go up, isn't it? And pick a red. What's the probability? 10 over?
Because we haven't picked from the red.
17. Yes, because we haven't picked from the red. So we still have, remember, at the beginning we had how many red marbles? 10. And blue, we had 8. Can you see that? So if we hadn't, we're here, right? We hadn't picked a red one, we still have 10 marbles that are red. Does that make sense? But we obviously have one less total number of marbles because we didn't put it back in the bag. Are we all together? Okay, right. Cool. So, but now, okay, so we've assessed all the different scenarios that can happen if we start off with picking a blue. Now we need to go back to if we start off having picked a red. Okay, so there's the probability that we could pick another red, isn't it? This is 9 now over 17, 100%. And then obviously if we pick another blue, it would be 8 over 17, 100%. Everybody happy? So these are the different pathways, and this is why we do decision trees, because if you're trying to do this mentally, it might be a bit of a challenge. Okay, so here the
So did they say how many apples we should pick from, like 1, 2, first, second, third,
it's only 2. Remember the situation was we were looking at the probability of picking 2 marbles, so we're only concerned with that. But we could go on forever with this. We could, yeah. So this first one, we're looking at basically saying, what is the probability of picking a red and another red as well, and another red, okay? Then here we're basically saying, what is the probability of picking, or maybe let me do it like this rather. This I think will make it, yeah, no, let me leave it like that. Blue, red and a blue, yes. Red and a blue. Okay, then here we're saying, what is the probability of picking first a blue and then a red? So I'll try blue again. Then finally, the probability of picking a blue and another blue. Okay, right. And remember, we're combining these events because the focus is we're looking at the outcome of having picked 2 marbles. We're not looking at the probability of this first event being the first marble and then the second marble. This is one event that we're looking at. So in order to actually calculate these probabilities, and we'll just calculate these probabilities, then we'll take a break. We're basically saying for the first one, we're saying 10 over 18 times 9 over 7. Okay. Second one, I should have just done all of them in a different color actually, but it's fine. 2, we are saying 10 over 18, thank you so much, times 8 over 17. Sorry, I forgot the one here. What does that give us? Then here, 3, we are saying 8 over 18 times 10 over 17. And here finally, we're saying 8, yes, sorry, over 18 times 7 over 17. Cool. Okay, right. So I think we can take our 10-minute break. And when we come back, we'll continue with this question.